Increasing, decreasing, and constant intervals. So I'm going to do a lot of visuals here. An increasing interval means that the function between the two x values has a positive slope. So m represents the slope, is greater than 0. So an example, a visual would be that the graph is going up and to the right, and because it goes up and to the right, that slope is positive. Decreasing means that the slope is negative. So the slope would be going down and to the right, and therefore it's a decreasing interval. And a constant interval just means that we have a slope of 0. The other concept that I want to talk about are maximums and minimums. We have two different types of maximums and minimums. We have relative and we have absolute. So again, I'm going to do some visuals. Now, a relative maximum means that it's a turning point, and it also means that there are y values that are higher than the y values at the turning point. So for example, these two spots right here would be relative maximums. So they're turning points, making them a maximum, but they're relative because there are other points in this function that have a higher y value. So for example, this point right here is a y value that is higher than the maximums in the picture. An absolute maximum, if I draw another picture, an absolute maximum means that it is a max and that there's no y values that are higher than that given y value. So this is absolute. This would also be a maximum, but this would be a relative maximum. So absolute means it's absolutely the highest y value in that given function. Relative, so a minimum. Here we have a minimum, and this would be a relative minimum. So it is a turning point, and that turning point is a minimum, but there is a y value that is lower than that given point. And here we have an absolute minimum because it is a minimum and there are no other y values that are lower than that specific point on the function. So this would be a relative min, and so would this. So here's an example. It says use the graph to estimate the intervals of increasing, decreasing, or constant and identify all extrema. So extrema is our fancy word for saying maximums and minimums. So the first thing we want to do is we want to estimate all of the turning points. So this turning point, this is just an estimate. I would say negative 1.5 and about 2.1. This turning point down here, negative 0.5 and negative 0.3. And this turning point up here, approximately 1.1 and 3. In class, we're going to learn how to find these extrema with the calculator, but right now we're just going to estimate it. So we want to identify the intervals of increasing or decreasing. So increasing means that the slope is positive. So it's going up and to the right. So I'm going to use my highlighter and I'm going to highlight all of the parts of the graph that have a slope that's positive. So that's in pink, and my slope that is negative, I'm going to make yellow. Now notice that there's a change from a positive slope to a negative slope at the turning points. Now I'm talking about positive and negative slopes, but don't forget that a positive slope is really identified as increasing, an increasing interval, and a negative slope is decreasing. So let's write those now. So when we write intervals, we write in terms of our x values. So if we start over on this left-hand side, the arrow continues to go down. So the x values with an increasing interval goes from negative infinity up to the x value of the turning point, which is negative 1.5. And then we have a second increasing interval, and that starts at negative 0.5 and goes to 1.1. Now the reason I have round parentheses on all of these is at the turning points, our graph is neither increasing nor decreasing. The decreasing interval would be the yellow part, which is between negative 1.5, so again I'm using the x value, and negative 0.5, and then starts again at 1.1 and goes to positive infinity. Now let's identify the extrema by name. So we have 3 turning points. We have negative 1.5 and 2.1. Now this is a maximum. And since there are y values that are higher than 2.1, at some point in the graph, this is going to be relative. We have another maximum over on the right-hand side, and this one is absolute, and that's because this y value is the highest point in the entire graph. Then we have a minimum, and this is a relative minimum, and that's because the y value of negative 0.3 is not the lowest y value in the entire graph. There's other y values, although they're not extrema points. There are other y values that are lower than negative 0.3.